Let's look at some features of ANSYS Discovery Live that truly make it a disruptive software for the product development process. You should know that everything I'm about to show you is performed in real time on a simple engineering laptop. No supercomputing clusters or cloud-based simulation infrastructure, just real-time simulations and real results. In this first example, we'll look at a complete detailed model of a tractor's rear axle assembly. I want to better understand where high-stress regions are located. I know there are several fixed locations and a force applied. Once I complete the minimum number of inputs, I can see exactly where the highest stress values are located. Normally, this type of feedback from simulation would take hours or days. In Discovery Live, it literally takes seconds. Based on that initial feedback, I want to reduce the stress in this area. I'll quickly add some ribs to the design, something I've previously mocked up, and once I merge everything, the results come instantly. I can see that the second rib doesn't appear to be helping much. When I remove it, I instantly see the new results, which tell me I don't in fact need that rib. Instant design direction on 3 iterations in less than a few minutes. We'll move to a fluid flow study where you'll see the same power and ease of use in Discovery Live. My goal is for the flow to uniformly distribute through both outlets. After I designate the inlets and outlets, results immediately appear. Discovery Live makes certain assumptions for you, such as the flow rates, so you can quickly see the results and trends. There are several ways to observe the results, such as streamlines, an LIC plot, or contours of velocity magnitude. Since most of the flow is going out the bottom, the question is what sort of changes can I make to remedy this? If I include a splitter in the geometry, I instantly see what effect that has on the flow. Of course, I can quickly change its angle to better equalize the flow. A flat baffle works, but I think I can do better. A curved baffle will probably lessen the pressure drop while better distributing the flow. Now, as I have new ideas, I can test them in real time. What happens if I translate the splitter? Results instantly appear. What happens if I add a second baffle? You can see how quickly I can analyze design ideas in a few seconds and better determine the best design direction. Let's look at a thermal study where I have an electronics enclosure. Inside there's a green control board and a pink heat source. My goal here is to perform a basic simulation of temperature on the control board. After applying a heat flow of 50 watts to the pink body, Discovery Live quickly returns final temperatures. Applying a plot of the temperature, you'll see I'm sitting around 72 degrees Celsius on the top face. Now is where things get interesting. In Discovery Live, my inputs are editable. I'll change the air convection to something more representative of natural convection instead of forced convection, and you'll notice the temperature increases over 4-fold. Quickly adding a primitive heatsink instantly drops the temperature, but I still have some room to improve. As you saw before, modifying geometry is no issue at all, regardless of the model's origination. Every time I add a fin, the temperature drops, and I'm sitting around 150 degrees Celsius now that I've doubled them. Any other edits I conceive are easy to do, and since my heatsink now interferes with the housing, I'll have to customize the height accordingly. It's simple to drag faces and fine-tune until I'm satisfied. I've changed the geometry and one input, but another input to change could be the material, and I instantly see the effect from doing that. At the end of the day, my questions are quickly answered in Discovery Live just as fast as I can change inputs or the geometry. In a final example, we'll jump into an external airflow study to not look for highly accurate lift and drag values, but to observe trends in the airflow around the vehicle. And as before, setting up a simulation requires minimal inputs to get instant simulation results. What I'm curious about is the effect that a top deflector will have. With a handy sketch tool, I can mock up my concept and transform it from 2D to 3D. The solution updates, and I have instant feedback. Discovery Live can also do unprecedented complex simulations, like showing instant results for the flow of 2 vehicles, all in real time on an engineering laptop. It truly is a powerful environment for designers to experience the benefit of simulation and take product development to the next level.